Knowledge is power. Well, that's what conventional wisdom tells us. And something we've learned from the big data movement in recent years is that one of the best ways to get knowledge is to acquire a lot of data, contextualize it, and use it to provide insights. If we take these together, then we might conclude that we should treat data as a commodity, as property, as something that we want to hold on to for our own and not share it with anybody else. Now, let's suppose, though, that that's not true. What if it turns out that sharing data is actually one of the best ways to contextualize it and turn it into knowledge? Hi, I'm T Allemang here in Columbus, Ohio, and I'm going to talk about 4 projects that take this idea and run with it, that explore whether sharing data might actually be more valuable than hoarding it. The first such project took place right here in Columbus, Ohio. Back in 2017, Columbus was the recipient of a Smart City Challenge, a $50 million grant from the United States Department of Transportation to develop smart city technology. Amongst the things that Columbus did with this was to realize that the city is creating data all the time. There's data about transit, data about recreation, data about utilities, data about people, events, all of this data, and that in order for a city to be a smart city, that we really needed to convert this data into knowledge and utilize it in the city every day. So, toward that end, the city has developed the Smart City Operating System. And right here we're standing in front of the Smart City Event Center, where a lot of the development of the Smart City Operating System took place. Let's have a look at the Smart City Operating System and how it works. So, as we said before, it is a data platform for curating, publishing, and sharing data about the operations of the city. The platform allows you to search for data sets based on any aspect of the city's operation that you're interested in. It indexes over hundreds or even thousands of data sets. Metadata for the data sets provides a faceted search for narrowing down the data sets. The data sets are available in a variety of formats, and each data set can be processed with a variety of data processing tools for visualizing, accessing, and combining the results of the data. This has resulted in a vibrant community participation in the development of Columbus as a smart city. Meetups, hackathons, and community projects have taken as a starting point the data and the Smart City Operating System and created applications that serve the city, improving accessibility to mobility impaired residents, improving accessibility by bicycle and other means of transportation, and feeding back into civic planning to improve the utilization of the city's resources. Data is indeed power, and this power can be shared with the people. For our second project, we're going to talk about data journalism and how the Associated Press uses data.world to publish its data. Back in the old days, the stories that you read in the newspaper were written by reporters who got their information from a number of sources, including what they called news wires, services like the Associated Press that would provide them with the basic stories that they would start from as building blocks for their own stories. Well, to a large extent, that's still true today. The Associated Press still provides basic news stories for reporters all over the country and all over the world. But nowadays, in addition to just stories, news relies on data, the data that backs up the story, the data that helps people prove what's going on in the story. That means that the Associated Press has moved from being just a source of stories to also being a source of data. That means that the Associated Press has a need to publish data. Enter data.world. What is data.world? Data.world is quite simply a social network for data. Just as you go to services like LinkedIn to post professional information, you can go to data.world to publish data. Data.world provides storage for this data. It also provides a means for integrating your data with other data sources. The Associated Press takes advantage of the data.world infrastructure to publish its data journalism. And so here on the front page of data.world, the Associated Press appears. You click through to the organization and you find a blurb about the Associated Press and a catalog of the data sets that they are currently publishing.
Not surprisingly, many of the current data sets have to do with COVID and the coronavirus, since this is one of the hottest topics at the time that this recording was made. So the Associated Press has made use of data.world as its primary publishing platform. As a citizen data scientist, you too can take advantage of the data sets provided by the Associated Press. Let's go for an example. The first one here is the Johns Hopkins COVID-19 case tracker. You can get some information about it here, or if you click through, you get further information and a sample of the data set. In the upper right-hand corner, you can explore the data set. This allows you to see not only the components of the data set, but also some queries that the folks at the Associated Press have already written to get you started on this data set. In fact, these might be all that you really need. These queries correspond to the raw stories that you could have got from the Associated Press back in the old days. So for instance, if we want to find the highest per capita caseloads, here's a query that finds that, and you can have all the data here. You can also write your own query in a variety of query languages that you can then share with your own public, put into your own blogs, and so on. Metadata about each dataset is available here to help you explore it. All in all, data.world is providing all the components you need for a social network for data curation, registration, and sharing with your community. For our next example, we're going to turn to molecular biology. We're going to start with the ENCODE project. ENCODE stands for the Encyclopedia of DNA Elements. One of the things that it does is to index a number of experiments on genes and the products of genes and the reactions that work with them. It provides a rather elaborate search engine over these. Someone who knows about molecular biology can use this to identify and experiment on a particular gene and some of the chemicals that react from it. Now we're also going to talk about a thing called wiki pathways. The way that molecular biology works in a living organism is that there are these chain reactions of one chemical producing another based upon the interaction of some gene. This could consume energy, produce energy, and have byproducts that are meaningful in the metabolism of the organism. Wiki Pathways is a database of the biological pathways maintained by and for the scientific community. As you'll see right now, the front page of Wiki Pathways is focusing on pathways about COVID-19. So when COVID-19 attacks a cell, for instance, there is some chain reaction of chemicals, a pathway that allows COVID-19 to do this. And many of these pathways are currently featured on Wikidata. Now, each of these is an open data set, and you can use them to search for pathways and experiments. But how can we cross-reference between the two of them? Well, Wiki Pathways already presents its data as RDF, as a Sparkle endpoint, so that's available. Now, the experiments in ENCODE aren't available as a Sparkle endpoint, but they are available in an RDF-compatible format called JSON LD. What this allows us to do is to take an experiment from ENCODE and in a combined query on data.world, where we have brought in the ENCODE data and hosted it on data.world, and where we write a simple Sparkle query, it's not even very long, that queries against ENCODE as well as Wiki Pathways. We can plug in that experimental URI, run the query, and that brings us to all of the pathways that are related to the genes in that experiment. This example has shown how when you publish data on the web, that a third party, perhaps even unbeknownst to you, can add to the value of your data by combining it with somebody else's data. In this case, the whole is greater than the sum of the parts.
Fourth example of shared data, we're going to use the recently released third edition of Semantic Web for the Working Ontologist. For those of you who aren't familiar with it, One of the things that this book does is to provide a lot of examples of data sets and queries that show off the way the semantic web standards can be used to query and link data. One of the most common comments that we had about the first two editions was that the data sets should be available for anyone to play with on the web. Now this provides the question, how should we best distribute these data sets? We could put them on a website, which we did, but that's not particularly interesting. They're not really alive. You can't query them. You can't link them to other things. We could put them on GitHub, which at least lets other people contribute to them, but still doesn't bring them alive. So we're going to show what we did do with these data sets in the third edition.
So just as we did before, we have a website for the book. All of the data sets are available for download on the website just as before. But the innovation is that now the queries are available on the website as well. So all of the queries are sorted by chapter, and the numbers of the queries correspond to the numbers in the book. And if you click through to any one of these, you get to a page that includes each of the queries. So you can examine the queries, run the queries, and you can even edit the queries. You can click through and go to the original data.world site where all of the queries and datasets are managed as resources on data.world. And you can see the same query here. Don't worry, your edits aren't going to make changes for other people to see. If you want to make contributions to the queries, you can do that as well, but that's a more involved process. Going back to the website, we also have a discussion group about each chapter and a general discussion for comments and suggestions about the book. These four examples show situations in which it is more valuable to share data than it is to keep it to yourself. I'd like you to think about your own data and look for opportunities to increase its value by using these methods for sharing.